This is Unit 4, Day 2, Reflecting Functions. Reflecting functions across the x and y axes is an important mathematical process. Although the general principle applies to all functions, we will explore this specifically for parabolas, so just our quadratic functions. Example 6, the parabola f of x equals x squared minus 6x plus 5 is shown on the grid below. Consider the function g of x is equal to negative f of x. Determine a formula for g of x. Don't forget parentheses are distributed. Okay, so basically it's saying to get to the g of x, you're going to have to negate that f of x function. So when I negate that, that switches all my signs on the inside, which becomes negative x squared plus 6x minus 5. So all the signs change. So make sure you realize that. All the signs changed. Okay. Part B, graph and label that on the grid. So g of x, okay. If I were to put this in my graphing calculator and use my table of values, I'm going to get something that looks like this. And here we go. So right in red would be my g of x. So I just negated that. Okay. How is the graph of f transformed to produce it? It was a reflection over the x-axis. Okay, it was a reflection over the x-axis. Part D. Now consider the function h of x, but now the negative is inside the parentheses of the f function. Determine a formula for h of x. Don't forget that when you have a negative x quantity squared, it's positive. Okay, so for h of x, it's saying you would have a negative x squared minus 6 times negative x plus 5. So remember, guys, it's inside now. So before, up in part A, it kind of distributed everything and everything changed. But now look what happens here. X squared still stays x squared, but your b changes signs. Because my negative times my negative was positive, so only my b sign changed. So b changed only. Okay? Graph and label that on the grid. So I'll make this graph blue. When I make this graph blue, it produces this graph. So if you compare the original black graph to my blue graph, which I am now calling h of x, you can see that this is a reflection over the y-axis. So part F says, how was this graph transformed? That is a reflection over the y-axis. So one thing that we just learned is when the negative's on the outside, it's a reflection on the x-axis. When the negative was inside the parentheses, it was a reflection on the y-axis. So basically this little box here is summing this up, guys. This is really, really important. So the negative was on the outside, it was a reflection over the x. When negative's on the inside, it's a reflection on the y. Example 7. Determine an equation for the linear function g of x equals f of x for both a reflection in the x and the y. Now remember, reflection of the x says take negative g of x. So that means you put it on the outside and you distribute it to everything on the inside, which would produce negative 5x plus 7. So remember that little thing I wrote in red, all the signs changed. So this became negative, this became positive. A reflection in the y-axis keeps it in parentheses, so it would be 5 times negative x, but then minus 7. So only that first sign is changing, which is kind of like your b. You just don't have an ax squared there because it's linear. Okay, so there's those two. Example 8. If a parabola has the equation of f of x equals 2x squared minus 3x plus 8. Which of the following represents its equation if a reflection of the x-axis? So x-axis, you think, negate the whole function and you distribute it. So that would be negative parentheses 2x squared minus 3x plus 8. You change all the signs and it would produce negative 2x squared plus 3x minus 8. So again, change all the signs, and that is going to be choice 2. Example 9. So now it wants a reflection in the y. Now y means you're going to put that little negative inside the parentheses. So it would be negative 4 times negative x quantity squared minus 7 times negative x plus 2. Now this stays positive because negative x squared is positive. So that first term did not change. It still remains negative 4x squared. But your b changes to positive 7x plus 2. So that's why originally when we were doing parabolas, I said only the b sign changed. So it's going to be negative 4x squared plus 7x plus 2, which is choice 1. Example 10. Consider the function g of x equals negative x squared plus 4. What two transformations have occurred to the graph to produce y equals x squared to produce the graph of g? Specify the order in which the transformation occurred. Note that there exists more than one correct answer. Make your own sketches to verify. All right, so you should notice two things here. You should notice this negation, and that negation simplifies a reflection. So first I have a reflection over the x-axis. So the parabola flips over the x-axis. But then you should notice the plus 4 is a vertical shift up 4. So that was going back to day 1. So that's a vertical shift up 4. Okay, so it's getting flipped and shifted up. So if you wanted to see like a little sketch of this, here's my parent graph. So here's what a normal quadratic of x squared would look like. So now the whole thing is going to flip upside down like this. Okay, but then that yellow parabola has to shift up 4. So now if I went up 1, 2, 3, 4, I'd have it upside down and shifted 4 there for that g of x function. Okay? Example 11. The graph of f of x is shown below on 2 grids, so it's the same one there. Sketch A, the graph of f of negative x, and B. Okay, so this one you have to recognize. This is a reflection over the x-axis, but when the negative is on the inside, that's a reflection over the y-axis. So they want us to sketch both. Okay, so reflection over the x-axis for the first one is you're just going to flip every point. So this one was 1, 2, 3, 4, 5. That was 6 above the x-axis, so your new vertex will be 6 below. Okay, and then everything else is the same pattern here. This one was 3 below, this one goes 3 above. Okay, and same thing over here. That's 3 below, this one goes 3 above. Oops, this one I counted wrong. 1, 2, 3, 1, 2, 3. So it's going to look something like this. And it hit here as well, and it hit here as well for that reflection. Oops. A little off here. So this is negative f of x, so reflection over the x. Now the next one is reflection over the y. So if it's on the line of reflection, it stays. Then everything else just kind of shifts. So this one is 1, 2, 3, 4 away, 1, 2, 3, 4 away. This one reverses. And that one is 1, 2, 3, 4, 5 away, 1, 2, 3, 4, 5 away. So I flipped every point, or I reflected every point over the y-axis. So this is f of negative x.